Okay, now let's talk about reduction of order, okay? This is very special technique for the case like if the coefficients are not constant, okay? But we can determine the different solution if one is already given, okay? That is the case, okay? One is given, but the other is not given, okay? And since the coefficient is not a number, I mean, not the constant, we cannot use characteristic equation at all, okay? But this can look at that. Look at the example, okay? Y1, the first solution is given for differential equation. That is definitely second order linear differential equation, but non-constant coefficient, right? Then, first of all, like even like Y1 is given, but like we would love to double check it is really solution of the like given differential equation now, okay? So that is the verified process. Let's see, okay? The solution. How can you do it? Like for this one, since this is second order, we need y prime and y double prime, right? Y prime is minus t to the minus 2, and y1 double prime is minus times minus 2, which is positive 2 t to the minus 3. And plug in everything into the differential equation. Then my differential equation will be 2t squared times y double prime. We found it, right? 2t to the minus 3 and plus 3t and y prime, which is minus t to the minus 2 and minus y, which is t to the minus 1. And then if that is equal to 0, then we can say y1 is the solution of the differential equation, right? So let me double check, okay? It is equal to 4t squared times t to the cube is t to the minus 1, and minus 3 t times t to the minus 2 is t to the minus 1, and minus t to the minus 1. Look at that, 4 minus 3 minus 1, which is equal to 0. Then we just checked it, okay? So the given y1 is not a fake, right? And then now, let me show you what is the reduction of order, okay? So here we go. Basically, all these techniques start from this consideration, okay? We're gonna say your y2 will be the form of the v times y1, which is given function, right? So vt times t to the minus 1. That is my assumption, and this is working, okay? So like the purpose of like this whole process is we have to find the function v, okay? So to do so, we're gonna do the same process with the verification thing, okay? And we're gonna find the y2 prime and y2 double prime and plug in back into the differential equation, okay? So let's do it, okay? Then y2 prime is v times t to the minus 1, which is product rule, okay? Don't forget this one. You have to do the product rule. I'm talking about calculus 1 step, okay? And for first one prime, v prime times second function plus v times minus t to the minus 2 second function prime, okay? Simplify a little bit. It is equal to v prime times t to the minus 1 and minus v and t to the minus 2 now, okay? And also, don't forget, we need y2 double prime, right? So y2 double prime is equal to, oh, like we have like two terms, right? The first one is also product rule, second is also product, okay? We have to product 2 times, okay? From the first one, v prime prime, double prime, t to the minus 1 plus v prime times t to the minus 1 prime is minus t to the minus 2. That is came from v1, okay? Let me try to use different color, okay? It should be much better, okay? I'm gonna write same thing, don't worry about it, okay? From this guy, it is v double prime t to the minus 1 plus v prime times minus t to the minus 2. That's what I'm saying, okay? And from the second part, minus v times t to the minus 2, it is another product rule, which is minus v prime t to the minus 2 and minus v times negative 2 t to the minus 3. That's it, okay? We should simplify a little bit, okay? This one is equal to v double prime t to the minus 1 and minus v prime and t to the minus 2 and minus v prime t to the minus 2 and minus minus plus 2 v t to the minus 3. Is okay? And also, as you can see, in the middle term, these terms are same. So we can rewrite this one as v double prime t to the minus 1 minus 2 v prime t to the minus 2. That's it. Now we are ready. You know why we are doing this, okay? We assume your y2 is equal to v y1, which is v t to the minus 1. And we found y2 prime and y2 double prime. And we're going to plug in whole this thing into the given differential equation. Is that okay? So let me rewrite my differential equation here. Then my differential equation was 2t squared y double prime plus 3t y prime minus y equals 0, right? Then we're going to plug in this guy into here. And where is y2 prime? Okay, this guy, y2 prime here. And y is v t to the minus 1 on top of the, okay, I mean, it is here. This is what I'm going to do, okay? Then, okay, let me update. 2 squared times v double prime is, y double prime is v double prime times t to the minus 1 minus 2 v prime t to the minus 2 to v and t to the minus 3, okay? And plus, we have 3t and y prime we need, which is v prime t minus 1 minus v t minus 2, right? And then we need minus y, which is v t to the minus 1 equals 0. That's it, okay? And keep that in mind. All this process is like, to find v, right? We have to find v, okay? So let me simplify distribution and cleanup, which is 2t squared times t to the minus 1 is 2t v double prime. And t squared and t to the minus 2 canceled out, and negative 4 v prime. And then plus 4 v, and we have t squared and t to the minus 3, which is t to the minus 1 now. And second part, distribution again, and 3 v prime, and minus 3 v t to the minus 1, and minus v t to the minus 1 equals 0. Simplify one more time. And we have only one v double prime term. They write again. And then let's see. Can you see this one? Minus 4 v prime and plus 3 v prime, which is negative v prime. And then 4 vt minus 1, minus 3, and minus 1. These are gone, right? And that's it. That equals 0. Again, we are trying to find v, okay? But here, we're going to use the reduction of order, which means like, look at that. The very bottom of the, this process, it is 2t times v double prime minus v prime equals 0. It is second order, right? But since there is no v term and we can reduce your order, that is the reason why the title of this one, this technique is reduction of order, okay? Here we go. This is reduction of order, okay? Let's do define new function u for b prime, okay, which means first order just reduce to 0, right? Then what is u prime then? B double prime. These are, you know what I'm saying, right? Then when you replace your v as u, then that one can be written by 2t u prime minus u equals 0 now. It's first order linear differential equation, okay? There's two ways to solve this one, okay? We can do the integrating factor, or this is totally separable, okay? So let me show you how we can do separable, okay? So let me try to rewrite this one as 2t times du dt minus u equals 0, okay? And move your u to the right-hand side. Then 2t du dt is equal to u. Then divide by u on both sides and divide by 2t on both sides and multiply dt at the same time, okay? Then this can be totally separated 4. Are you okay so far? Okay, so keep that in mind. We are trying to find v, okay? So first we're gonna find u, then we can find v, okay? So, okay, then we're gonna take the integral on both sides. The left-hand side is ln of u, and right-hand side is ln, if we consider like 2 as the coefficient, then we can like 1/2, then it can be written by 1/2 ln of t, and we need constant c. Is okay? Then we're gonna raise e on both sides. Then this will be e to the ln u is u, right? We practice a lot, right? And e to the 1/2 ln t plus c, right? And then this can be written by c times e to the 1/2 ln t. You know what I mean, right? We did this before, right? And then re-raise your 1/2 up there and cancel out e and ln. Then I can say your u is c times 1/2, no, t to the 1/2. Is it okay? But like, what is u, by the way? It was v prime, right? Okay. Now, b prime is c times t to the 1/2, right? And just simply take the integral one more time. Then you will have v, right? So v is equal to c times 3/2 2/3 t 3/2, and you need another constant k. Okay, whatever, you can use c1, c2, whatever, okay? But let me use k for this case, okay? And that's it. This is my v, okay? And where was v? It was like y2, right? y2 is v times t to the -1. Am I doing right? Was it -1? Yes, yes. And then that is c times 2/3. Okay, it might be better to write 2/3 c, right? 2/3 c times t to the 3/2. No, bad writing. 3/2 plus k and t to the -4. Okay, distribution. Okay, it is equal to 2/3 c. T to the 3/2 -1 is t to the 1/2 plus k times t to the -1 now. Okay, that's it. Okay, but can you see this one? It is exactly linear combination of t to the 1/2 and t to the -1. Well, like in the problem, t to the -1 was given y1, right? So actually, like even I wrote y2, but it's not y2, just like y. That'll be fine, okay? Because we're gonna define y1 and y2 again one more time. Define y2 again. Okay, because like this, t to the -1 is y1. Then we're gonna say t to the 1/2, which is independent with t to the -1, is y2. Definitely, we have to check the Wronskian is not equal to 0 for this case with y1 and y2. But like it is obvious, okay? When you calculate this one, Wronskian is not equal to 0, okay? Then we can say y1 and y2s are the particular solution which form a fundamental set of solution, okay? Does it make sense? So finally, we found y1 and y2. Then general solution is C1 y1 plus C2 y2, which is a linear combination form, okay? So we can say t to the -1 and t to the 1/2 form a fundamental set of solution, okay? And this is reduction of order.